you with all the building blocks so that you can build applications, right? So let me get started. So when you're choosing API for building with the LLMs, what is it that you typically look at, right, while using that? Because for me, as a developer, there are a few things that matter. First, of course, is how usable is it? Then comes performance. Cost, again, is a very important factor. Again, from what I've seen in my career of almost 25 years is that no two applications are the same. So you need the API to be flexible. You need to customize it to build the applications of your choice. And let's see how Gemini 2.0 with the GenAI SDK is trying to solve this problem. So I'm Laxmi. I'm a field solutions architect with Google Cloud. And in my day job, I kind of help businesses build GenAI solutions, show them, the art of the possible. And I also work with developers, enabling them to build the solutions using Vertex AI. Basically, tell them what the models are, what the APIs are, and how can you build, and then kind of help you in whichever way we can. Okay, so I've got a packed content here. Hopefully, I should be able to go through all of that. But we'll kind of start with the basics, right? So, what are these models? What is the new SDK? And then, how do you kind of start building with it? I would also kind of cover the multimodal aspects of it. How can you kind of analyze a video? Then, as developers, how do you kind of use the code generation and execution tools with that? Again, I'll briefly touch upon how can you do data extraction with Gemini, one of the more or say most complicated problems in the data processing space. And of course, we would kind of end it with something on Imagine 3, right? So that is just for you to kind of explore. I will not be going deep into it, but I'll kind of show you what is possible. We'll follow it up with some Q&A, but after this, we do have the networking as well. So if we run out of time, we can talk during that time as well. Okay. So last week, Google launched 3 models in the Gemini 2.0 family. So we have the Flash, we have Flashlight, and we have Pro. Right. So naturally, the question is, what are these 3? So all of these 3 models, they handle multimodal inputs. You can give it text, audio, video, images, PDF. And then all 3 of these models will give you a text output. They also give you something called a structured output. I'll be kind of touching upon it in one of the examples. All of them support function calling as well. And then coming to the differences between them. Flashlight has only text output. It doesn't have an image output. It doesn't have an audio output, right? And then Flash and Experimental have these multimodal outputs in various stages, right? Some of them are in experimental stage, some of them are in private preview. So private preview would mean that they're kind of behind an LO list and you may or may not have access to that. Then the context window. Flash models have a 1 million context window, whereas the Pro has a 2 million one. Again, the ability to use Google search as a tool and code execution as a tool. So this is not supported in the Flashlight, but the other 2 support these functionalities. Again, we'll be touching upon these functionalities in the code. So when should you use a 2.0 Flash model, right? So this is a model which is GA or generally available. And suppose you are using, say, 1.5 Flash, and you kind of want to upgrade to a significantly better quality, then you could go in for a 2.0 Flash. Or if you're a 1.5 Pro user and you want better quality and improved latency, that's when you could go in for 2.0. And this being a GA model is something that you can use for your production applications. So coming to the flashlight, right? So just as the name suggests, it's the fastest and most efficient model, right? Again, it doesn't have any multimodal outputs, although it supports the multimodal inputs. What you could do is if you need something which is in a 1 million token, 1 million input context, so you could go in for this. Again, it's a upgrade path for 1.5 flash users who want better quality, but for the same price and speed, right? So you don't kind of spend anything more. Um, Again, coming to the Pro model, it has got a 2 million context window. So if your application is into processing some text or any data which is kind of long context or which is into coding, or you have other requirements on that, which we will come into because what it supports, right? You could kind of get into the 2.0 Pro model. So again, this is in experimental as we speak. And because of that, you would basically have some quotas and limitations, which is kind of provided in the website. So we spoke about these three models. And then how do you kind of use them, right? So to use them, you should have a SDK. And Google released something that we call the GenAI SDK, which is different from what used to exist before this. Currently, it is available in Python, Go, and Java. It's quite easy to install it. So I'm basically a Python developer, so I would be talking primarily on the Python package. Quite easy to install it. Pip install Google GenAI, and then from Google import GenAI. So that's all you need to do to get it to work. Okay, so what do you do? So you did a pip install, you did the required imports. So what you have to do is first create something called a Vertex AI client. Again, this is a very simple, what do you say, a command. So you just do a GenAI.client. You set it as Vertex AI equal to true because we are kind of working on the Vertex AI platform. Then you set your project and location. I'll show you what these are when I come into a notebook, but you could use this GenAI SDK with 1.5 and 2.0 models. You can't use it with the 1.0 models, right? And you still have the old SDK or the pre-existing SDK, which supports 2.0 models as well. So it's like kind of backward compatible as well. Cool. So next, I kind of just show you how easy it's to kind of just show you those commands, how it's easy it's to kind of handle the different modalities, right? So as I told you, input is multimodal. You would have text, you would have image, video, everything. The kind of, and suppose you want to kind of generate the content, it's all the same, right? So you've already created a client, and then you have to do basically a client models generate content, and then you give the model details, and then you give a prompt. And if it's a video, then you basically have to create an object for the video with details like what would be the URL of the video and what is the MIME type. So this is essentially the same, whether it's a PDF document, an audio, or an image, or you could even use a local image, right? Okay. And then again, the generate content API that I showed earlier, that is one option. And then suppose you want to generate streaming content. So you will have to use generate content stream. So that's how simple it is. Everything else remains the same. Again, if you want to do asynchronous IO, then you have to do a client AIO models dot generate content. So what I'm trying to kind of put across here is the simplicity of using this SDK. It's not, I would say the learning curve is not too steep. Okay, so with that done, let's kind of get into two examples, right? So when we code or when we kind of try to develop an application, you have one part which is doing something with the generative AI model, but then you do have downstream applications which kind of use the output of this one. Again, one of the challenges is the format, right? Because you need to parse what is coming out of an LLM. And this is where you could kind of use controlled generation, right? So you could ensure that the output which the models give, they are sticking to a specific schema, right? And then again, what happens is, suppose you kind of uh, ask Gemini to kind of do some kind of a reviews, right? And then it might give your label as say good or say bad and then positive and everything. Because but then what happens is, if you have a downstream application and you're kind of trying to work on those labels, it becomes difficult for you to process that. So what again control generation does is it kind helps you control the output and the labels that you have. Again, function calling. So there are multiple ways in which you can use function calling. And by function calling, what I mean is that, suppose you have written a function which say connects to something in your there's an API already existing which fetches some information for that, right? And you need that information to be processed based on the inputs given by the user. So that's where you will kind of use function calling. And the way you can do that, the traditional way has been to use the open API specs to define a function and then call that. Or you could also do a automatic function calling. You could also set it to any. So these are the multiple options that are available in the GenAI SDK with these models. So what I'll do is I'll kind of show you the code and I'll kind of run them so that we don't run out of time. So I'll be sharing all of these notebooks in the GitHub. Uh, you can take them, run them, right? So when you kind of log into a GCP, into Vertex AI, you would see something like this at the top. So this is what I call the project ID earlier. And then you've got different regions. I would basically be running it from the US Central one. So as I said, like do all the installations, restart it, authenticate it if you're kind of trying to run this from a collab, and create the client, set the model. So this is with Flashlight. You do have the safety settings. You can configure the other parameters, right? The temperature, toppy, and so on. And this is what I was kind of talking about, the control generation, right? So I'm kind of asking the model for a popular cookie recipe. And what I say is that this is the format in which I want the response to be. So I need a name, a description, and the ingredients. And what you have to do is basically in the config, specify that the output has to be a JSON, and this is the schema that you need. Where once you do that, you get a output in this format, which kind of becomes very easy for you to parse in a downstream application. Again, the other example that I was talking about is like you are trying to do some kind of a sentiment analysis and you want the sentiment to be positive, negative, or neutral. So you kind of force it upon the model saying that, these are the enums that I'm defining and give me an output in this format. So back to, so again, I talked about Gemini 2.0 series being multimodal. One of the use cases that we have is video analysis, right? So it could be you have a video, you could always upload it into a GCS bucket, or if it's a publicly available URL, you could just pass it on and then use that URL directly, right? And then what can you use it for? Suppose it's a very, very long video on something, right? You don't have the time to listen to it. Ask Gemini to summarize it for you. Or if it's a video and then you kind of want to understand when a particular event happened in that video, you could also kind of ask that, right? So it's like, at what point in the video is Harry Potter shown? Or you have another video, you want to kind of chapterize it. Again, another example. Or if you're kind of putting out an ad, and then what happens over here is you want to kind of say identify moments in that. It could be your logo. You kind of want to you're making an ad and you want to know that how many times is my logo being shown out there, right? Or is it could be anything of that sort, or is it like moments of happiness, moments of this thing, or what are the other events that are happening out there. All of these would be some use cases of uh, Gemini 2.0 for a video input, right? So I'm just kind of telling you a few of them, but it's up to you to kind of use it in your use cases and then analyze it the way you require it. I'll also kind of touch upon the multimodal live API and then kind of get into the code. So I guess some of you would have seen some videos out that. So with multimodal live API, what happens is you have a very, very low latency bidirectional voice and video interactions, right? So what I'm going to show you today is how to use the API, but you could always, build a front end to it and then kind of use it with the camera of your phone or your computer and then kind of ask questions on that. So if you've kind of watched some of the YouTube videos with that, it could be like, there's a coffee machine out there, you don't know how to use it. So kind of just show that and then ask Gemini to tell you how to kind of operate it. So these are a few of the things. And this multimodal live API, as of now, can process text, audio, and video. And the output is only text and audio as of now. Again, it retains the memory of all the interactions in a single session. And as of now, the session durations are up to 15 minutes for audio. So with this, I'll just show you how to kind of use that, right? Again, we are coming back to the GenAI SDK. We are using getting into the async mode out here because you could kind of talk with the model, and then when Gemini is kind of giving you a response, maybe as audio, you could always interrupt that and then get into the next question for that. It's again very simple. Construct your message, send it, and then wait for the response, right? You also have a set of parameters that you can use to control the output of that. It's a stateful API. So I would kind of, show you how that works. Uh, so this is the YouTube example that I had. So again, this is an ad. And what I am trying to do is, summarize this. So again, what I want to kind of focus out here is how you kind of make that object out here, which is just the YouTube URL, and you specify the MIME tag, generate content, and then your prompt or something as simple as summarize the video, and then kind of gives you a quick summary of what's happening out here. Then again, what identifying the commercial entity. So let me just play this for a couple of seconds, and then awesome. So there you see that there are some stores which are kind of displayed out here. And what I am asking Gemini here is like, list all unique commercial entities present. And then along with that, I also need a start time and a end time, and then kind of, give a explanation for that as well. So it kind of lists down these are the unique commercial entities that are there, and then at what point does it come, and then why that is being shown. Right. So this is the kind of information that you can extract from a video with a simple prompt. Coming to the multimodal live API, again, right, there are, I think, around, yeah, 5 voices which are supported there. What you could do is connect to this again with the GenAI SDK, give the model, give a configuration. The configuration basically consists of what is the response modality. It could either be text or audio at this point, and then you could also choose a voice that you need. So once that happens, and suppose you need to understand something, right? So say, explain the encoder and decoder of a transformer, right? So you just do this, and you run this, and then this is the kind of output that you would get.
To a numerical representation, while the decoder generates the output sequence. The encoder processes the input.
So it's kind of, you could also have a audio. You could also have an audio input out there. So essentially, what you would be doing here is talk to Gemini, right, and then interpret it as required. Again, from a developer point of view, one of the tools that multimodal live API supports is the code execution tool. Quite easy to set it up. So sorry, it's not a Google search tool, it's a code execution tool. But yeah, Google search also can be used as a tool out there, right? So as before, specify the modality, specify the tool, and then specify, the generation configs that you have. Once you have that, you know, send this input, and then you could kind of, see the output that you get, and then ask follow-up questions. So here, for example, what I've done is I've asked it to write code to calculate the 15th Fibonacci number and then find the palindrome. It gives you the whole code, and it also kind of gives you, the answer to both of these questions. And then, the follow-up question could be, okay, I have this code, write a unit test case for me, right? So it would kind of do that. You could kind of run that with all the limitations of the session that I mentioned about. Because it's still in the experimental stage, it still has a lot of restrictions on the session this thing, right? Okay, so with this, let's kind of go back and then cover, I think, which would be the last 2 use cases. Second, I would say this is one of my personal favorites, tabular data extraction, right? So tables, they come in all forms, right? So it can be bordered, semi-bordered, borderless, and then some of them might have titles on one page, and once you kind of get onto the next page, you won't have it. Layouts can vary, then the text wrapping, and then if it's a scanned image, then you have all the OCR problems with that, right? So here we'll kind of take a look at how Gemini is trying to address this problem, or what's the kind of output that you get with Gemini. And then I'll also kind of take you through Imagine 3, right, which is Google's image generation model. Again, coming back to my point, it is that one same SDK. Instead of generate content, all you have to do is generate image, right? And then you have a set of models which are supported. Imagine 3 version 2 being the latest. You could also configure things like, what are the number of images, aspect ratio, and all of there's a whole list of parameters which is kind of available there, right? And then what can we do? So one is obviously the text to image part, right? You just give a prompt. And then a question happens. It's like, okay, there's a prompt, but I am not an expert, which is very true in my case, right? So how do I kind of know what prompt to use? So you can also have a prompt enhancer. So just set it to true and it'll kind of make a beautiful prompt for you to use it, right? You can enhance these images. You could also do edit parts of the image. Also, there's a fine tune the model with whatever specific set of subjects that you have. So with that, let's kind of get show you the code of that. So let's start with the table example. So I'm kind of skipping all the initial stuff. You can take a look at it. So I've kind of taken a screenshot from this website. And this is the profit and loss account. So this is, one of, I would say, a kind of tough table to process. One, because it's not like there's a separate column for the key and then another one for the values, right? So there are places where it's mixed. Some places like this, the label or the key is kind of multi-line. It's not in one place. Also, there is the numbers, right, which are not exactly aligned and so on and so forth, right? So then there is something aligned there, but the sum kind of comes up on the other corner. So this was pretty interesting in that uh, you know two prompts here. So here what I'm saying is extract the amounts of cash purchase, cash sales, net profit, and discount receivers from suppliers and provide the response as a table. So the prompt is as simple as that. So this is the values that I want, and I'm telling Gemini to extract that. And this is the output that we get, right? So simple. And then the other problem is validating the calculations. There are so many values out there. So how do you know whether it is right or not, right? Again, so what I'm saying is validate if the net sales and net purchase amounts are being calculated correctly. So here, what I'm asking is about the net purchase and the net sales, right? So which is basically it has to add two numbers and then subtract something else. Um, Again, with this prompt, the answer is it kind of tells you these are the values and what is the returns, and then this thing, and it kind of tells me that those numbers are right. Okay, so next one again. Uh, I'll be sharing all of this code, so I'll be just concentrating on the image generation part. So here, what I've done is for Imagine 3, there's two models. One is Imagine 3 version 2 and the fast version. Again, the speed and hence the quality of the generations vary. But all you have to say is a prompt like, artistic depiction of Italian pasta with tomato sauce being prepared in a rustic setting. Number of images is one. You have the aspect ratio. This is a responsible AI flag. What is the output image type that you need, right? So this is for the fast imagine. And then with just that prompt, this is the kind of images that you get. So you could kind of change the settings, rerun it to get an output, right? Again, for somebody like me who has a challenge writing prompt for an image, what I could do is, okay, I need the picture of a cozy reading nook, right? And what I could say is set the flag enhance prompt equal to true. So what happens is behind the scenes, Gemini takes this prompt, makes it much better, and then kind of gives an image like this. So what you could do is try it first without with your prompt, then see the enhanced version, see how different it is, right? And then once you have this, you could kind of edit it and then change it. Again, upscaling the image. Suppose you kind of want to use it in some of your presentations, make it. And here my upscale factor is by 2. So yes, so this is how this gets upscale. And then I think these are all the notebooks that I had. And before I get into the Q&A, I'll give you the links of where this is there. So all the code that I have will be in this GitHub repo. And you have any questions, feel free to connect with me as well. Right. So uh, maybe I'll just take 2 questions and then rest we can talk during the. Yeah, sure.
Thank you. Anybody have a question for Laxmi?
That's one.
right here.
Thank you for the sharing and the amazing model. I have a question that if I want to turn my home's dash cam into a smart surveillance camera to know when my mother come home, and so follow 2 questions. The first one, how is it possible to fine tune the model to know who is my mom? And the second one is if I turn on it 24 hours a day, what's the approximate cost? Is it feasible? Thank you.
So I think I'll kind of skip the first question out it. I'll kind of, because it's a kind of a long wound answer. I'll kind of connect with you during the networking time, right, for that. And then again, for the cost, so currently for the multimodal option of it, it's an experimental. So the cost here may not be the ones which you have when it goes GA, right? So you could kind of look it up and then look at how it is being priced. And then, look at what the API calls are there. And again, the session, right? So it's like right now, it's a small number for a video with audio in that, right? Yeah, and we'll connect. Yeah, sure.
The imagery and the painting. I have a degree in art history and I had my own photography business. And I've been really impressed with the generation of unique and original images, but it's been very challenging editing the images and having the model respond to prompts for editing and adjusting an image. It seems to want to generate a new unique image every iteration, as opposed to being able to accept the command to simply make adjustments to an image. Have you been working on that aspect of it?
Right. So I think a version of editing is still, under the LO list or one, right? Where again, it's kind of trying to address the same problem, where you have an image, and then how can you kind of keep it the same, right? So it's kind of evolving, and I would say the next versions might be better than what you have seen so far. But I completely get your point that you have an item, you're trying to change it, and you're trying to change it, and the editing, it kind of changes the whole initial image itself.
Thank you.
Hi, so I'm a Google Pixel 9 user. Okay, so we had Google Assistant, which does all the automation tasks for you. Like it can make calls, search on map, and then we have Gemini 2.0 in Google Pixel, which works as a LLM. So I was curious, like which model of Gemini would do the task which Assistant performs and even the Gemini performs. Yeah.
Um, so I would say as the models evolve, the decision would basically be quality, latency, and cost, right, of what you are using. Depends on your use case would be my answer. So on the what do you say, the kind of say the image that you need to process, right? And the volume of the data or the volume of the images that you need to process, and what is your acceptable latency and the cost,
Yeah.
right? So it would be, I would say, I wouldn't say that, just use a specific model,
Yeah.
right? I would say kind of, find out what works best.
Yeah, so I was curious about, like if we write a prompt on Gemini on Google Pixel, it should perform like, it should does the automation task for you. Like, you can say Gemini, call this person. It calls, or, it finds the best person to call. Like, yeah, I was curious about that.
Yeah,
Yeah.
yeah. So maybe I'll kind of talk to you later. So
Yeah.
just in the
All
interest
right.
of time,
Yeah. Thank you.
so would it be okay if we kind of connected during it? Thank you.
I think we have one more question.
Yeah, so I have a question about the video analysis. So what is the length of the video and context size correlation? So
Uh,
how do I know that if you have a 1 million token or 2 million, whether those will suffice for the given video length? So
right,
how do you determine that?
right. So if you look at the documentation, you will see that if it's a video with audio, if I remember right, it was around 50 minutes, if I remember right, what gets supported, right? Maybe I'll kind of look it up, but if it's with just audio, you would have another number to it. Yes, it's there in the documentation. I could kind of give it to you.
All right, I will try fast. I use Gemini at work, where we have a lot of documents, and it's on the top of documents to generate response. And do you have any advice how to validate it? Because for now, it's only human who validates all the time the results. So how you do that at Google, and what would you recommend to validate how it works, Gemini?
Right. Yeah. So, multiple ways you could do it. You could kind of do a grounding on RAG, right? Which is like RAG is your database, or say your set of documents that you have. And then suppose you're kind of answering it, you could kind of have Gemini return snippets from those documents, right? So that could be one. You could also have a test set initially when you kind of evaluate the model, see how the model is performing, right? So you kind of build your own ground truth. So these are the 10 questions. These are the right answers for that. And what is it that Gemini is giving me? And then you can use one of the evaluation technique to see how good the model is performing on that data set, right? And then again, depending on that, you could kind of do that. So maybe I could kind of explain it to you a bit more while we talk on that. I think with that, I'll end. I'll take the question.
Sorry, I think Holly, for time's sake, maybe we can do the Q&A later.
Sure.
Would you mind? Thank you so much,
Thank you.
Laxmi. Please welcome Alex from SAP.
Hello, everyone. I'm Alex. I'm from SAP, and before I properly introduce myself and get into my talk, I just want to say thank you to Laxmi for that wonderful tech talk. And also thank you to everyone for being here and the event organizers. So thank you all for all of that. Yeah, so my presentation is going to be LLMs at work, challenges, misconceptions, and the road to interpretability. A little bit more about me before I dive in. I'm a software engineer at SAP. You guys may have heard of that company, I'm not sure. But my team is the strategic customer engagement team at SAP, and that's honestly a lot more than you need to know, but we work in R&D, and so as a result of that, I've been able to work on a bunch of different projects, and thankfully, at least from my perspective, I've been able to work with LLMs. And so what I want to start about with my talk about is with my work on LLMs, and then go into a little bit the challenges, the frustrations, maybe the misconceptions that occur with working with LLMs. And then I want to pivot slightly to go ahead and talk about how we can understand LLMs. And for those of us who don't really have access or the ability to understand LLMs, to go ahead and understand black box models and maybe build our way up from simple black box models to very complicated black box models. So without further ado, I'll go ahead and start. So the first project that I want to talk about that I got to work on was a SAP coding assistant. And right here, you're going to see a little Python script going on. But essentially what was going on is that first we had a natural language processing script to go ahead and get the most important parts of documentation for coding languages and pass it into the LLM. And for many of you, this sounds like RAG. Well, this project actually occurred before RAG was a thing. So this was around the time of GPT-3, GPT 3.5. So very early days of the LLM hype wave. And at that point, LLMs were kind of underpowered. They weren't super great. And so the idea here was that, okay, well, if I ask a question about an SAP esoteric language like a BAP or CAP, it really struggles. So let's see if we can parse the documentation pages of those esoteric languages, provide the most relevant context to the LLM, and have it answer. And to kind of pair with this idea, we also integrated this backend service into a code editor. We wrote it as a VS Code extension because SAP's Business Application Studio also uses the same extensions. And you could go ahead and directly use the SAP-specific coding assistant within your code editor, which is great, convenient, very nice, but as things progressed and evolved quickly, we had more powerful LLMs, we had more powerful integration tools, and so projects like this didn't really make it out of the POC stage because we have, Copilot, GPT 3.5, 4, 01, and so on and so forth. Things just got better, and so you don't really have a need for this. And so our next iteration of POCs with LLMs that worked quite a bit better, and I think might be slightly more valuable or stay around a bit more, is having this natural language to SAP SQL application. So essentially you can talk to your data. So for those of you who aren't familiar with natural language, that's essentially what a computer scientist would call English. And so in this case, you can type in a question to your database that's SAP specific, and it'll, utilizing the LLM, get you back your data and some dynamic graph visualizations if it's appropriate for that query. And so in this case here, we have a very simple natural language command. It's appropriate, we execute it on the SQL query and give you back a table. Again, this is more of a sample, and this project has iterated since then, but I think this is an example of an LLM project that makes a little more sense long-term because yes, these LLMs are getting better at writing database queries, but the convenience of having it directly with your SAP specific context is very valuable rather than having to go back and forth to go ahead and take your data table information, and fulfill like all that information that the LLM needs in context to go ahead and execute a good query for your business use case. But again, kind of maybe to formalize these challenges and misconceptions, the one that I really want to hammer home is that LLMs just evolve very quickly. And this is just a kind of brief picture of what's to come in 2025. As you can tell, there are a lot of LLM models coming out, and this doesn't even include DeepSeek and some other popular and very powerful language models. So when developing these LLM projects and LLM applications, it becomes difficult to figure out a great use case because what's, to stop Google, OpenAI, or a different company to essentially upgrade their LLM such that in a month, 2 months, 3 months, whatever it is, that your application or your layer on top of the LLM no longer really provides value. So that has been a pretty big challenge in trying to come up with ideas and develop applications that will work and stick around long term. And this second point kind of goes hand in hand with that first point, and it's that LLMs behave differently. So here I have a very small example of two smaller models and lesser known models. But the first row essentially is just describing Newton's laws, and the next row is going to describe like a Thursday checklist. And there's some minor differences between the two, which might not seem significant. But in an application context where you need things to be more so consistent, this can be very problematic. So not is it only problematic going from different model types, but also just staying within the same model. So if you stayed at 3.5 and went to GPT 4.0 and 0.1 and 0.3, how they behave is different. And so it's very hard to keep this consistency. So between them evolving quickly and them behaving differently, it's very hard to have good support structure on top of an LLM to provide a viable business product or even build a viable startup that will last long term. And then the last point that I did want to talk about here was a small misconception, I think, in working with LLMs. I think a lot of people think that LLMs have to be right the first time. And I think that's coming from the idea of traditional software where you're frequently correct pretty much all the time. So it's like, what, 99% of the time your software system is supposed to stay up and running and working. And with LLMs, that's not really the case because we have hallucinations. But the thing is, LLMs offer us a way to solve non-traditional software problems. And so it's a bit of a trade-off of, do we want to solve this very difficult problem, 70, 80% of the time, or do we just not even want to try it? And so I think there needs to be a bit of a expectation realignment, both from users and from businesses in what LLMs provide and the space that I guess they exist in for software purposes. And here I have just a small, tiny example that I'm sure most of you have encountered to some variation of, where you ask the LLM a very simple question, it gets it completely wrong, and then you ask it again and it's able to correct itself. And yeah, this is silly and doesn't seem maybe super applicable, but in a software setting, this is kind of where chain of thought comes into play. If you have the LLM consistently iterating upon itself, you can more consistently get better answers. And again, this comes to maybe being able to solve those difficult questions where you need dynamic code or some other sort of magic box. And that's, I think, where, again, expectation realignment is needed. And maybe to not be a total Debbie Downer and go into some ways that we can make just LLMs better and not just say it's very difficult and it's impossible to work with. How can we utilize LLMs effectively? Most of you who have worked with LLMs have probably seen these tools or methods before, but the first one I'll discuss is retrieval augmented generation, also known as RAG. And I mentioned this one a bit earlier, but essentially the idea is as you ask the question, so as you have the prompt and it goes into the language model, you're simultaneously providing these retrieved documents into the language model. And these retrieved documents are coming from your database, and ideally they're useful to solving the problem. It's essentially giving the language model as much context as possible to solve a difficult question, similar to how a human would want as much information as possible to answer a difficult question, say on like a test. And this helps a lot in getting better responses and also getting correct responses in situations that you wouldn't normally get. So for us, this was very critical, especially in 3 and 3.5, and before LLMs were super powerful. Now, it's still useful, but questionable with the evolution of how powerful LLMs are getting. But the cool thing about RAG is you don't necessarily need to have a ton of input-output pairs, which the second method does require. So fine-tuning is another very common method to go ahead and get the most out of your LLM. So essentially, whatever LLM is being offered, so the pre-trained LLM from, say, ChatGPT or Anthropic or whatever company you're using, you frequently are given an API to go ahead and provide input-output pairs, so example text, example completions for whatever your task is. And you can kind of train a little bit further to get a fine-tuned LLM, and this fine-tuned LLM will have this in mind and then be able to give you better answers, especially if it's seen that in its fine-tuning, but also give you answers more in the style of whatever you fine-tune to. So on their own, fine-tuning and RAG probably aren't the solution. Combined, they're very effective techniques. But I think the third technique that I'm about to talk about that probably needs to be used more, albeit is a very difficult technique to use, is probably the most effective of the three that I'm going to mention so far, which is validation. So it's essentially, you have an LLM call, you pass it into some sort of validation call, whether that's another LLM, whether that's some sort of solver, something else, but something that you can verify that whatever it is that you're generating is correct or incorrect is very valuable. And if it's incorrect, you can have this kind of iteration to go ahead and correct whatever is going on and provide a better answer and iteratively get closer to the correct answer, at least ideally. But again, validation on its own, probably not ideal and also very difficult because it's hard to automatically validate whatever the LLM is generating, especially if it's something more subjective. But again, in an ideal world, you have all three of these, and validation, I would argue, probably plays the most important part in the three of them. And this is kind of where I want to pivot a little bit and go into maybe the interpretability aspect of LLMs and potentially the fourth method and very underutilized method of how to get the most out of your LLM. And LLMs are mostly black box models. For those of you who don't know what a black box model is, it's essentially when you only know the input and the output coming out of the model. Everything in between is very mysterious. You don't know much about it. It's not very helpful to whatever it is you're trying to do. LLMs are very much like this, although there is research being conducted to change this. And I think it'd be probably the biggest, I don't know, value change if we got more information in the step-by-step process from the input to the output. And an example in this case might be, if you knew the step-by-step process, you might be able to have a better idea of how correct the LLM is. Alternatively, you might know LLM limitations, and then you might know how to circumvent those limitations. And then an additional example might be just showing your steps. Sometimes that's very valuable for certain contexts. And so I would argue that this might be the most important way to get the most out of your LLM. I'm going to go a little bit more into what that looks like. And for those of you who aren't as into the literature here, the field that is currently really hot that talks about uncovering these black box models from, or getting more into the black box models that is the LLM, is mechanistic interpretability. And mechanistic interpretability is a very new field. And I'll just go ahead and give you the definition straight from Anthropic, who's probably the leader in this right now. And mechanistic interpretability seeks to reverse engineer neural networks similar to how one might reverse engineer a compiled binary computer program. Additionally, I'll also give you DeepMind's definition, another leader in this area. They define it as the field of study of reverse engineering neural networks from learned weights down to human interpretable algorithms. So maybe to step back a bit from this, because it might seem a little jargony, essentially what we want to do is have a bottom-up approach. Understand what the fundamentals of the model are, and ideally understand them in a human interpretable fashion, not just some way that kind of makes sense to a model or like the model as in the LLM or a different model trying to learn what's going on in the LLM, but from us, like our perspective. And that's why I really prefer DeepMind's definition, because it has this explicit mention of that breakdown being human interpretable. And to go a little bit further into this field of trying to understand LLMs from a fundamentals perspective, I'll briefly cover what is pretty much state of the art coming from Anthropic. And what Anthropic does is they have this box right over here, which is the SAE box, and that stands for sparse autoencoder. And essentially what a sparse autoencoder is doing is learning what parts of the LLM are associated with the text being generated and how strongly that connection is. And why this might be useful is in this example, well, we see this little text box here at the bottom that has text about freshly baked bread, the dog wagging its tail, a restaurant piece, another restaurant piece. To you, what might stand out is the dog wagging its tail. That feels a little weird and not very valuable to the prompt. Well, if we pass the prompt with the what's going on within the LLM into the sparse autoencoder, it can go ahead and recognize that, okay, the dog wagging its tail is not being strongly activated here. It's not as important to the generation of this text. Therefore, it's probably not as useful to this prompt and just kind of irrelevant. The other pieces, on the other hand, will activate a little bit more, and as you can see here, are highlighted more strongly, and so they're more relevant, more likely to be meaningful features, And then at the end, once you've kind of gone through this two-step process, you would go ahead and classify what you get back. And in this case, it's a little subjective, but you could say that, okay, we're talking about restaurants, we're talking about food. That seems to be the most important part of this text. Chances are, like, the meaning here is food places. And within our neural network, the corresponding parts that are activating are probably tied to food places. So if, for example, we went ahead and amplified how they're acting within the neural network, we would expect the neural network to go ahead and give us more food-related answers. And for those of you who have seen Golden Gate Claude, this is kind of a very, very similar process. That's what's happening with the mention of it, or with it mentioning the Golden Gate Bridge very frequently. So not everyone has access to LLMs. It's very hard to get into, and maybe with DeepSeek, that's getting a bit better. But where can you realistically start? So maybe you'd want to start with something simpler. Maybe you'd want to start with something very basic and see, is it the same? Is it different? What's going on at a far more simpler level? So let's go ahead and dive into a very simple neural network problem. So this is probably one of the first neural network introductions you'd get in a computer science class. And essentially what's going on here is handwritten digit classification. So we see that handwritten digit 4 on the very far side. That is what's going to be passed into the neural network. So that 784 is corresponding to each pixel within the image. And the second layer, which is right here, and that will basically be picking up on some patterns from the 4, and the next layer will also be picking up on patterns from the previous layer, and the final layer, ideally, will be putting all of these patterns together to identify what the 4 is. And I'll get into why I say ideally in a second, but if we were to ask a human, how would you break down this problem, and how would you go ahead and come up with an idea of how to identify digits, you'd probably want to go ahead and break up digits into important subpieces. So like a 9 might be a circle and a line, an 8 might be 2 circles, a 4 might be those 3 lines. And so then whenever you're past something that has 2 circles, you're going to say, oh, that's probably an 8. Or if you have a circle and a line in that orientation, it's probably a 9. And so to maybe make that a bit more concrete, in the neural network example, in that input, that first layer, we would have the handwritten digit. In the second layer, those circles that are lighting up would go ahead and correspond to important subpieces of the 9. And then the next layer would go ahead and take those subpieces and make slightly larger subpieces, again, important to that digit, so in this case, the 9. And then the final layer would take that 2-part subpiece and identify a 9. Ideally, that's what we want to happen. Does it actually work this way? And the answer to that, quite frankly, is no. So this is a slightly modified architecture here, just so you could kind of have nicer visualizations. But again, on the far left, we have the digit being input, so that's the 7 as an example. The FC1, or fully connected 1 activations, is what the first subpieces are looking like. And that just looks like gibberish to me. I don't know if anyone can make sense of that, but I certainly can't. Similarly, the second layer, the fully connected 2 activations, also gibberish. So this is where we would expect to see more connected pieces that are important to whatever the digit is that we're classifying. And finally, at the end here, we have a little graph that's just showing what is the digit that the neural network thinks is being passed in, and the most positive value is the digit it thinks. And in this case, the most positive value is a 7. So it's correct, but I don't know why it's correct. I don't know how it came to this answer. It probably learned some patterns that are not really learnable by humans, and that's the most optimal technique. But that's, I don't know, kind of unfortunate. And we see this across other patterns as well. So if I pass in a 2, we have intermediate gibberish again, and very confidently 2 is an answer. If I pass in a 1, again, intermediate gibberish, 1, again, confidently as an answer. So when kind of getting into mechanistic interpretability myself, originally what I wanted to do was play around with this example and get into feature extraction. But instead, the thought I had was, what if we just make it work in an interpretable way? What if on the way to the optimal path for the neural network solution, it could go ahead and make a little pit stop and go ahead and learn some features that we understand? That would be really useful even if we sacrifice a little bit of performance. That'd be fantastic. And so to go ahead and test this out, what I did was I took the handwritten digits, I went ahead and got their horizontal edges and vertical edges, and the reason for this is a little bit arbitrary, but essentially it's very easy to programmatically get these edges, and said to the network, hey, when you get to that optimal solution, what I want you to do is make a small pit stop and try and understand what these intermediate features are. Try and understand that a 7 corresponds to these edges. And well, when running this network, and this is again slight modification, so I'm doing a little bit of modifications underneath the hood. It's not the exact same neural network from what I originally talked about, but to make the example work, I made some changes. And what happens, or what we see, is that, okay, the part that's supposed to show horizontal activations is showing horizontal activations. The part that's supposed to show the vertical subpieces is showing the vertical subpieces. Suddenly we have something that's understandable. Okay, this is cool. We can work with this. One thing I'd like to note, though, to a baseline comparison where we don't give the neural network any incentive to learn these substructures, so we have the random gibberish situation, we are far more confident in our answer, which is something to note. I don't know how important that is. Maybe you don't want that in your neural network because maybe a 7 kind of does look like other digits, and so you don't want it to be absolutely confident that the answer is a 7. So I don't know, something to consider there, but we can pretty consistently get some amount of intermediate understanding. But again, at the end, we get the correct classification, but not super confidently compared to the gibberish. And then the same thing happens here with 1 as an example. And so the question that we need to revisit is, can we make it work in an interpretable way? And the answer that I have is maybe. And what you might be thinking right now is, hold on, didn't you just show me some slides that make it interpretable? And well, the counter I have to that is that on the way to learning the global optimum, because we're toying with it and don't fully, or at least I haven't fully dove into the exact process that's happening here, not yet at least, it's possible that we happen to learn those human interpretable features on the way. That is possible. But for a toy problem like this, what's probably far more likely is a quote unquote happy coincidence where we just so happen to kind of associate these edges with those digits. And so in this case, it might be more of a case of the neural network is still able to get to the optimal solution or whatever the local minima was previously with this, extra incentive to learn extra features. And so we've kind of solved for 2 things while still holding to the global constraint. And so that's why I would be hesitant to say that, yes, this is working. I would want to continue this research in this toy problem. Hello? Okay, sorry, I thought it died on me for a second. But we'd want to continue to do this with more complicated networks and essentially different ways of testing to verify that this is truly interpretable and that it is truly learning those sub pieces. But maybe one thing that is in favor of it potentially learning those sub pieces, those horizontal edges and those vertical edges, is that when we go ahead and pass in random images. So random images in this case are going to be basically white and black pixels scattered all over that handwritten digit. So it looks like essentially TV static. If we go ahead and take a look at the total activations normalized, the neural network here with the incentive to learn the features is in the blue bars, and that tends to more evenly distribute its answers than the network that's untouched. So the network that's untouched, which is those like red salmon bars, is consistently saying 8, which doesn't really make sense to me. Why would you consistently say 1 number for random noise? I would argue that for random noise, what you'd want is a more even distribution of answers, because if I were to ask you what digit is random noise, I don't know how you'd confidently be able to answer 8 every single time. So maybe this is an argument for that we did actually learn something. And with that, I'm at the end of my current research. So basically, I hope that I have sparked some questions and thoughts about interpretability, going deeper and learning more about models, whether it's large language models or just simpler models, and not necessarily diving right into building things and abstracting on top of things, but truly learning what the fundamentals are doing. So
Thanks a lot. Anybody have questions for Alex?
Thank you. Really nice presentation. I enjoyed more the first one. I will explain later why. But one question, you mentioned that the big problem right now is that we are getting more and more different models every month, almost, and we cannot predict actually what will be the response. It's not consistent. So if you're building the system that wants to show some value, to solve some problem based on the response, how you think we should tackle that, make a system that is more agnostic, like LLM agnostic, so you can replace the model without praying that that will not break anything that you built that will rely on the response of the model. So how you think about that, and how you think you should tackle that?
Yeah, so I guess in that case, it's difficult, but I think one potential solution, and there's trade-offs to this, is taking a model that you think is powerful enough for your business application and freezing it. So I think at this point, like DeepSeek R1 is a very strong model that can handle a lot of problems or be built on top of and do a lot of things well. And since you can run it locally, you won't have to worry about weights changing in that case, or model evolution. The concern there is obviously that you're going to be sacrificing power in the long run. So I think you at some point have to kind of accept this is the best I'm going to get and just build in this direction, or try and build that model agnostic framework, which I think is difficult to do because it will be constantly shifting. Maybe you can have an LLM write it for you.
I mean, I have feeling that everyone is selling shovels right now with new models. Like, oh, we have a new model, just go and dig the gold. But the gold is actual the value that model provides, and that's something that we need to figure out when we are implementing that in the businesses. So yeah, thanks for presentation. I think
So I moderated a couple of panels on deep tech in the big healthcare conference, JP Morgan Healthcare Conference in January. And, I had, it's much easier in my case to be a moderator with 4 smart people on the panel, much smarter than me because I get all my questions answered. So what we wanted to think about is, where is there so much bias in the models that you've got to step back and say, you got to kind of use some common sense. And I think overwhelmingly, and these were mostly VC guys, so it wasn't, general audience type people, but what happens is they said it was really Politico type things, that there was so much bias you couldn't clean it up. Now, I used the example in the election that I was able to get 20-to-1 odds that Donald Trump could carry all 7 swing states. Now that was way beyond what you should have gotten, because it was only, the polls were only a point or point and a half difference. And, clearly you saw in 1980 with Jimmy Carter and Gerald Ford, a real small margin of error, just tipped it. The same thing with Obama, just a few things. And so what happens is that there's a lot of places, I think, that you really want to see a level of predictability, because it's good to understand these models, and my kids know how to do it. I don't know how to program these things, but it seems like there's certain things that you've still got to use, common sense and really look around. And unfortunately, too many of the model makers only talk to themselves. And in San Francisco, liberals only talk to liberals, and conservatives are just scared to talk to anybody, right? Unless they got a couple bodyguards. So yeah, so I don't know if you comment about that, or is that a discussion when you build these models?
I mean, I guess the thing I'd say there is that we don't want to ignore common sense, but maybe in this case, common sense is like the traditional software models, which I don't think will get replaced. I see LLMs as taking like a new space, but I do think it is valuable to have, I guess, more open discussions about LLMs and not just have it in the power of just a few companies. So I think like DeepSeek democratizing their model was a very good thing for AI and OpenAI in general, which funnily enough, OpenAI doesn't do, is a good thing to have.
Yeah, I have 2 questions. One is, just now you said about DeepSeek. I thought that was a very big deal because they brought the they brought the foundation model to be in the reach of a small guy rather than in a multi-billion-dollar companies. And what do you think is the main reason? Is that the data they generated and they fed it to the LLMs was not going through some supervised training, but rather reinforcement learning type of thing? That's what I read. I don't know. And second question I have, in general, in LLM, what is the metric you use to figure out quantitatively the bias? How exactly you will say this model, let's say Anthropic model or some OpenAI or let's say DeepSeek, which one has less bias for a given set of prompts which are given as an input to it? So is there something you can run on those models to figure that out, or how exactly you figure this out?
Sure. So I guess I'll start with the optimizations from DeepSeek and I guess just lowering costs. So from my understanding from the paper, a lot of that does come from the fact that they went underneath CUDA and they went kind of like one layer below what someone would typically do with writing machine learning code. And in that case, you're able to optimize more because CUDA is kind of more of a generalist framework and kind of makes everything in machine learning work. And because of their GPU constraints with the old version of GPUs that they had, to get the most out of them, they had to kind of subvert that layer. The other thing that was interesting from the paper was that they changed the ratio of mixture of experts. That it gets into a lot of detail about something else, but essentially it makes the network run more efficiently and not waste as much GPUs per inference. And I believe also, maybe not during training, I think just during inference. But for your second question in terms of evaluation metrics, in general, I think those are difficult, but in bias, I think that's probably even more problematic. I don't know that even the AI community has a great answer for that, because even with the sparse autoencoders where we're trying to like classify features, we are using LLMs for the classification process, which I don't know, to me feels a little bit like using the definition to define the word. So ideally, if we could separate those things a little bit more and not rely on the model that we're trying to learn about more to help us learn about the model, that would be great. So I don't know that anyone has a great answer yet for evaluation metrics. Maybe like some sort of like LLM combination approach to average out. I don't know. I don't think there's a great answer there right now.
Two quick questions. The first is should be really very little, fast and easy question. Did you train the images? Were they 8-bit images or 16-bit images?
16, I believe.
16. And well, I would ask you why you didn't train them on 8-bit.
I think this was probably a decision that I didn't think about too hard, and I was kind of just excited to dive into the interpretability research. So I don't have an answer for, I guess, why I chose 16 over 8. I guess generally speaking, more precision is good, but I don't know if there's a reason for, like, I'm open to hearing your, like, I guess, motivation for the question if why I should use 8-bit versus 16.
Because that's the standard, I think.
Okay.
So, and then the other question is, have you tried getting two LLMs to argue it out?
In terms of just an answer at the end?
Just a good old-fashioned debate, a battle of words, you know, not a fight, an argument.
Sure, like for fun, but like never anything seriously or like them looping together. It's entertaining, but I don't know. I haven't built an architecture where we're having like two LLMs debating for an answer to a question.
Thank you.
I work in the field of software security, and while I understand all traditional problems associated with any software system, and all applies to actually AI as well, but when it comes to, let's say, model poisoning or prompt injection, what I'm struggling with is that how to see all of these in a most pristine form in a simple model by doing, not with the million pages literature. Do you have any idea like sandbox or something already there?
So essentially, like, how do we prevent code running on our systems and like, I don't know, anything malicious that could come from that?
Yes. So I think if you ask me, I can consume a model and try playing with it. But I'm just wondering if you already have some kind of sandbox or some way already there by which I can have that example and play with it to see, it's a very basic level, just not by literature.
Right. I guess for like security reasons, when my team would release this to customers, we would do it in a Docker container so that if anything goes horribly wrong, it's mostly contained. And it'd be very difficult to break out of that kind of system. So that would be, I guess, my recommendation for playing around. Although I will mention I wasn't as much in charge of designing those considerations, but yeah, I would go to some sort of containerization for that answer.
No, but those are still infrastructure issues, basically. So my question is that so let's say if you're talking about identity, encryption, storage, tokenization, et cetera, they are all infrastructure. I mean, these apply to any software system. But when we talk about prompt injection, I mean, is there any way or sandbox to see what exactly I changed and at the model level, what happened that it is being called prompt injection?
So like basically, why did the malicious behavior happen?
Yes.
So there is some amount of research happening on this going on by Anthropic again. I'm sure DeepMind is as well, but I'm just a little more familiar with the Anthropic research. They work with the recent paper they released, I don't know, a month or two ago was on alignment faking. And they kind of go into this detail of the model pretending to be good. And this also is part of the question here because the LM could be deceptive in whatever it's trying to run. But from an interpretability perspective combined with an alignment perspective, ideally what you'd be seeing is what's going on at the activation level. So what parts of the network are being fired most commonly, and in the mechanistic interpretability lens, you can identify specific nodes that are more likely to trigger for certain nefarious contexts. I don't know if they have found one specific to code injection, but I know they have found some stuff that I think was related to racial bias, if I'm recalling correctly from the paper, but it's been a while since I read that paper. I'd point you, I think, towards scaling monosemanticity was the paper from Anthropic for more details there.
Okay, I'll catch up after this, yeah.
Yeah.
Thank you. Thank you, Alex. It's very good talk. My name is York. I wonder that whether the LLM can deal with this kind of a problem or not. Suppose that my company is running SAP with ERP system, and President Trump just increased the duty for steel for 25%. Can I ask SAP, say, what is my bottom line afterward? And can LLM deal with this kind of problem, or we need another kind of agentic AI to deal with this problem?
Sure. I would say, I guess in theory, yes, but practically probably not. I just think the amount of information you'd need to give the LLM there and the amount of iteration it would have to do is probably beyond the cost and time of having the LLM do it, at least at the current moment. Maybe if LLMs get more powerful and we crack computing, maybe with quantum or something like that, maybe it becomes more feasible. But as of now, I'd say practically probably no.
Thank you for the great presentation from you, Alex. I have a question regarding the interpretability, because I think when I try to use DeepSeek, it gives me the thinking process of how it achieves the answer. And I'm wondering whether this is a kind of interpretability you define in your presentation, and whether there are a kind of research on we will train the AIs with the thinking process from AI kind of thing, and how to avoid kind of using the wrong data and wrong data generated by AI to lead to wrong and bad results kind of thing.
Yeah, so I guess in terms of the interpretability portion, I would lean probably more towards no on that. And the reason I'd say is because I think, and I could be wrong here on DeepSeek specifically, but generally the chain of thought and showing the reasoning tends to be from input-output pairs and iteratively prompting essentially what's going on behind the scenes. I know Llama was trying to do something without trying to pass the actual word tokens and actually just go with I think it was the multi-layer perceptrons back into themselves, if I recall correctly, which is maybe a bit better in that regard. But yeah, I guess that's kind of a slightly better version of if you were to try and go step by step with the prompt with something that wasn't showing you chain of thought. And then I think I may have missed the second part of the question there.
Sorry, the second part is about whether we would also consider to train the models with the thinking process, because the AI have their own AI thinking process, and it's a kind of data AI generated. And will we also use the AI generated data to train AI kind of thing?
So I know, I don't remember the exact companies off the top of my head, but there are quite a few companies that are using synthetic data generated by LLMs to train the new LLMs, or at least toy around with that problem. And then in terms of having the AI maybe like think or in a human interpretable way, right now, at least with Anthropic, it seems to be less on focusing interpretability imposition. So like what I was demonstrating is something that I don't think is really toyed with, and there's good reason for that, because you're introducing bias into the loss function. So essentially, you're overriding what the model is trying to learn from the patterns. And one of the fundamental rules of machine learning is that the model kind of knows best. So the idea here is that hopefully there's a small trade-off with, you know, us interrupting the model and introducing like human interpretable ideas and not losing too much accuracy. So in that case, like I would say at the moment, I'm unaware, it might be happening, but I'm unaware of like LLMs being trained to essentially think in the way humans are thinking.
Thank you. All right, last one. All right.
Hi. So I should say that we should give some hope about SAP. So what I mean, what stands for SAP? As we know, systems, applications, products. So now we have all these transactions. Already we know, we used to say function, and then now object-oriented method, now APIs, right? All is very clear, no concern. So we know our APIs, right? So now we have the data layer. Now we have AI, we have the systems in place. So we already now able to see our data in SAP very clear. So when we are talking about like LLM models, like something in general, it's hard topic. But for business applications, it's so clear because we are more identified for data, right? So with this ability, we have ability to train, and then we have configuration. What does it mean for each language? Also, we have like whatever the different languages, right? So we can identify even the personification. We have ability to do that. So we can train easily with those abilities SAP applications, and then we can utilize AI very easy. So because you know what I think now when we're thinking about like in general LLM, we lost the track how we can utilize LLM. So I think, you know, we are more secure in SAP side. Thank you.
I guess like the only part I'll add to that is you might know more than me. I haven't been at SAP that long, so it's, you know, possible it's above my pay grade. So yeah.
All right, guys, truly last question.
Alex, do you know a way to reduce the verbosity of the responses in DeepSeek? I'll give you an example. I asked it to generate a Python print statement to round a number to do 2 decimal places. No verbosity, be succinct. It still went off on its typical fishing expedition.